In this video, we're going to do a quick review of the difference between ionic and molecular compounds. So we've seen elements, and they're found in a periodic table. And as you know, you can take elements like Lego pieces and connect them together to make bigger things called compounds, or sometimes just molecules. So let's take a look at what a compound is. It's when you connect two or more different elements. So that's key word, they're different elements. And they're connected by something called a bond. And that bond is essentially the valence electrons connecting the elements together in some way. So compound, two or more different elements chemically combined by a bond. And so again, that bond is the valence electrons. An example would be NaCl. There's two different elements connected together. There's sodium and chlorine. Or let's say H2O. Two different elements connected together. Now, the compounds that exist can be of two types. There could be ionic compounds or molecular compounds. Ionic compounds form by a transfer of electrons, and that means that there's going to be ions that are involved, because when elements lose electrons, they become positive, and when they gain electrons, they become negative. And so ionic compounds, the elements in there are joined by what we call an ionic bond, which is basically an attraction between oppositely charged ions. So in NaCl, what we don't show you there is that the Na is positive and the Cl is negative. And so what happened is that there was a transfer of electrons leading to opposite charges, and now that they're oppositely charged, they are attracted to each other. And so this would be considered an ionic compound, where the elements are held together by ionic bonds. So you can take a look at this picture below here. We have sodium, which is the metal. Metals, remember, they lose electrons. So this metal is going to lose its electron. That electron is going to go to a non-metal, chlorine. It's going to gain its electron there. And so after sodium loses the electron, it becomes positive. And after chlorine gains the electron, it becomes negative. And now they're attracted to each other. And so this is the compound NaCl, sodium chloride. You might remember from grade 10 that you name the metal first, then the non-metal, and you change the ending. Usually, ionic compounds form between a metal and a non-metal. There are some exceptions, but this is the general rule. We'll see exceptions later. One more thing to mention about ionic compounds is that they actually don't exist like this. They don't exist as single, let's say, NaCl molecules. There's no such thing as an ionic compound molecule. Rather, ionic compounds exist in these little crystal structures over here. So this crystal structure is called a crystal lattice. It's basically just a whole bunch of ions clumped together in this crystal structure. So you have basically a bunch of Na and Cl. So for example, the green would be Na plus, and the purple would be Cl minus. So we have Na plus and Cl minus, just repeating in that pattern over and over and over again. So there's no such thing as a single NaCl, but rather they exist in crystal lattice structures. And that's specifically for ionic compounds. So summary here, compounds can be two or more different elements chemically combined by a bond. That bond is due to the valence electrons doing something. The compounds can be ionic or molecular. An ionic compound is one where you have a transfer of valence electrons, and so you have ions that formed, and those ions are bonded together by opposite charges attracting, and so we call that type of bond an ionic bond. And ionic compounds usually form between a metal and non-metal, as you see in this image over here, but they don't exist as little individual molecules like this. They actually exist in these crystal structures like this. So you can't say there's a salt molecule. It's really an NaCl crystal structure or crystal lattice. So we'll do one more drawing example to make sure we understand how ionic compounds form, and then we'll go take a look at the second type of compound called molecular compounds. We will see this in more detail throughout the first unit, but I'm going to do a quick example And what's more important right now, is that you understand the concept as opposed to be able to replicate this 100%. Just understand this concept first. So here we want to form a compound between K and O. At this level, we know that potassium is a metal and oxygen is a nonmetal. And so what that means is we're going to have an ionic compound that's going to form because we have a nonmetal and a metal bonding together. So what I usually do is I draw out my metal Lewis dot structure, and I put my nonmetal Lewis dot structure as well. Remember, it's the valence electrons. So 1, 2, 3, 4, 5, 6. Okay. Now, potassium wants to lose electrons and oxygen wants to gain them until it has its full valence shell. So this potassium is going to transfer its electron over to oxygen. But what you'll notice is that that's not enough yet. That's not enough to have a full valence shell for oxygen. But potassium doesn't have any more. So simple solution, let's call another potassium in. So a second potassium is going to transfer its electron to the oxygen there, or where it's missing over here, sorry, right there. And now that's enough to fill the oxygen valence shell. And so what we end up with is something that looks like this. We have, let's make her Lewis dot structures for ions, K plus. We have 2 of these. So I'm just going to put a 2 over here because 2 of them were involved. And then we have O, 2 minus. And the reason I put X's there is to show that those came from the potassiums. So this is how the compound between potassium and oxygen would have formed. If you want to write this as a formula, you could simply put K, the metal first, there's 2 of them, and then the nonmetal after, there's only 1. You don't have to write the number 1 there, that's K2O. And as you remember from grade 10, you'd name the metal first. This is potassium oxide. You can try the same thing, so you can try to do this for the compound that forms between Ca and O. So do the same process, show me the transfer of electrons. So you have transfer as your first step. Show me then the ions as your second step. And then third step, formula and name. Step 0 is actually determining type of compound. So that's what you do at the very beginning. I realized this was ionic because there was a metal and a non-metal. To figure that out, go back to your periodic table to double check if they're metal, non-metals, and you can go from there. Now, another type of compound that exists is a molecular compound. You might sometimes hear them called covalent compounds. And so the goal for these elements is the same thing, to get a full valence shell, but rather than transfer electrons, valence electrons are actually shared. So there's no transfer electrons, there's no ions. There's no ions because electrons are transferred. No ions, no transfer. And so the bond that connects elements in a molecular compound is called a covalent bond. Think cooperation, they're sharing, electron sharing. You would see that in CO2. So here we have carbon sharing with 2 oxygen atoms. There's electrons shared between these elements here. And so when you share them, they have a full set. So for example, by sharing, carbon has 1, 2, 3, 4, 5, 6, 7, 8. In reality, 2 of these are carbons. 2 of these electrons here are carbons. And the other 2 belong to oxygen. But it's like they're sharing to get a full set. So it's like if you collect, for example, I used to collect Pokemon cards. So I might have shared with my brother. He might have had some cards I didn't. I had some cards he didn't. And if we shared and put our electrons or Pokemon cards together in a binder, we'd have a complete set. So we're sharing. Rather than me going to steal his cards, we decided to share peacefully. And that would be a covalent bond, which makes molecular compounds. Molecular compounds usually happens between two different non-metals. Two or more different non-metals. There are exceptions, but that's a general rule. If you see only non-metals that are different, you have a molecular compound. So for example, CO2, these are both non-metals, so that's a molecular compound. You can still have molecules form by sharing. So for example, H2, this is a molecule, but it's not a molecular compound. It's a molecular element. And that's because it's the same, two of the same connected to each other. Here it's two different, so this is a molecular compound. But nonetheless, because it's two different non-metals connected to each other, this is still going to be considered a covalent bond that is holding them together. So we'll do a quick example of how a compound would form between two nonmetals. So here we have a nonmetal here, nonmetal here. So we have two different nonmetals, which means that we're going to have a molecular compound. And again, we're going to see this in more detail later on. Right now, I'm showing you a simplified approach to this, but just understand the main concept. So first of all, we're going to show that there's going to be a sharing that will happen. So we have hydrogen, Lewis dot structure there, chlorine, 1, 2, 3, 4, 5, 6, 7. Hydrogen needs one more because it only has one shell. Chlorine needs one more. So typically they're going to share the unpaired ones. That's why we like to draw them nice and paired. So these two are going to share over here. And so what we can do is draw them sharing. So now they're sharing. So here we identify which ones are going to share, the unpaired ones. And then once they're sharing, we can draw them just side by side like this. Cl. This is the shared pair. Sometimes you might represent it as HCl. So the shared pair could be represented as a line like that. Typically one line is called a single bond. And that just means that two electrons are shared in there. One came from the hydrogen and the other one came from the chlorine. Just to add, some of you may have seen this before. You might have seen this is more sharing. When you see lines, that's basically sharing. That's covalent bonds. If you see two lines like this is a double bond. It's still a covalent bond. It's a double bond. But instead, there's not two electrons, four electrons being shared. So two from O, two from C, for example. So there's two double bonds in this compound. You might also see triple bonds sometimes. So for example, you might have this. Here we have three lines. This is a triple bond. So rather than share two or four, here we have 6 electrons being shared, 2 electrons per line. Main idea here, though, is that you need to find the unpaired electrons, match them up, and then put them together to show that they're sharing. There's no transfer, no ions, so we call that a covalent bond. Covalent bonds can be single covalent bonds, which are just 2 electrons being shared, double covalent bonds, which are 4 electrons being shared, and then triple covalent bonds, which are 6 electrons being shared. And you're usually going to see that between 2 or more different nonmetals, but you can also see it between 2 of the same nonmetals, like H2, for example. So if I were to do this for H2, these two will share, so I can draw them like this, sharing, or I could draw it like this as a single bond. So again, understand what a bond is. It's basically the connection between the elements in a molecule or compound or molecular compound or whatever be the case. Regardless of the type of bond that forms, regardless of whether it's a transfer or a covalent type of bond, an ionic bond or covalent bond, it's the valence electrons that are responsible, which is why we always focus on those. So if there's a transfer of electrons happening, it's an ionic bond. It's a transfer of the valence electrons. If there's a share of electrons, we're sharing valence electrons, it's a covalent bond. So we already touched upon this, but just a quick difference between molecular compounds and molecular elements. So when we talk about molecule, a molecule in general is when you have elements combined by a covalent bond, not ionic. Remember, ionics exist as crystal structures. Molecules can actually exist as tiny little molecules. There could be, for example, a little CH4 moving around in the environment. This can exist by itself as a molecule. Molecules can be molecular compounds, which is two or more different nonmetals connected together, or molecular elements, which is the same nonmetal connected together. So that's why, for example, O2, even though it's two elements, it's not considered a compound because it's two of the same. It's considered a molecular element. H2O, on the other hand, is considered a molecular compound because it's two different elements chemically combined. So it's a molecular compound. So that being said, you should be able to explain why H2 is considered is not considered a compound, even though there's two elements there. So you can pause the video and try to write out a response, and then check if you're correct. So essentially, H2 is two of the same element combined. A compound must be two or more different elements chemically combined. So you can practice classifying these as molecular elements or molecular compounds. So you can pause the video, try it yourself, and then check your answers. O2, we know is two of the same, so it's a molecular element. H2, two of the same, so it's a molecular element. N2, two of the same, so it's a molecular element. CO, carbon and oxygen, two nonmetals are they're different, so it's a molecular compound. CO2, so carbon and oxygen, two different nonmetals, so it's a molecular compound. And then over here, H2O, well, two different nonmetals, so it's a molecular compound. None of these were ionic because these were only made up of nonmetals, but we had molecular elements and molecular compounds. Regardless of that, all of these were connected together by covalent bonds, a sharing of electrons, not a transfer. Again, you can do the same type of practice here. So you can pause the video and then retry this for yourself. You have to classify these as atomic elements, molecular elements, or molecular compounds or molecular elements. So H2O, two different elements, two different nonmetals specifically, so it's a molecular compound. Mg Cl2, this would actually not fall under any of these. This would actually be an ionic compound, ionic, because it's a metal and nonmetal. O3, the same nonmetal, so it's a molecular element. O2, molecular element because it's two of the same. CH4, all nonmetals but different nonmetals, so molecular compound. AU, be careful, it's not a compound because there's only one uppercase letter. Notice compounds have more than one uppercase letter. This is an element, and there's only one atom of it, so it's an atomic element. Atomic element, just the element by itself. Careful between these two here. Notice the CO with two uppercase letters. That's a molecular compound. It's two different elements because I know that because of the uppercase letters. Here we only have one uppercase letter, so this is the element, cobalt. It's the atomic element, just one atom of it. And then lastly, F2. It's two of the same nonmetal, so we have a molecular element.